Okay, good afternoon, ladies and gentlemen. Uh, what I will be discussing this afternoon is how to troubleshoot my 20-year-old leaf blower. Because the last time around, I was using it and it just go dead without any reason. What I thought originally was the connector here that goes to the blower. I changed it, but still the blower's dead. It's this one here. This was the original location of the plug. I thought there was a disconnection here because it got some burnt things. Okay? But when I replace it with this one here, I try to switch it on and still the blower is dead. I'll try to check my camera. The blower is still dead. So what I did, guys, is that I tried to open it this one. I bring out the blower motor, and as I check it, this switch was intact. So the one that created the dead condition is not this switch here. It's not even this one here. You know what? The one that created the dead condition. It's the okay. I will try to bring out the diagram here. If this is the blower motor, we got two brushes here, where the current will goes in coming from line 1. It will pass through the blower motor, then it goes back to line number 2. When I inspect it, brush number 1 is still intact, but it's too thin already, and brush number 2 was actually gone. So if you try to measure the resistance between line 1 and line number 2, it's actually an open circuit. So the remedy for this one here is just to, what they call this, replace brush number 1 and brush number 2, but how could you replace that one? So what I did, guys, I ordered a brush contacts from Amazon. It got how many sizes of this one? 2, 4, 6, 8, 10. This one comprises of 10 sizes of brushes. So actually, if you try to open it, there are so many size of brush contacts over here. So what you will do is choose the right one for the one that you will be needed. But I choose this one, but there's a little bit of discrepancy. Okay, so for this one to be inserted on the brush contacts container, because there's a plastic container here where you will insert the brush. But this one is a little bit bigger. But since we are technically know how to troubleshoot, the remedy for that one is just to grind this one a little bit. This is a crosshatch pile. So if you try to slide this one here, okay, you will be decreasing the size of this one. And as soon as the size will fit the container of the brush that's inside the motor, Okay, that will be the time that this will be the one that you will be using it. Okay, so what I did is that I just disconnect this one, I insert this one, I remove the old brass contacts, and I just solder it by using my soldering gun. Sorry guys, I didn't show you how I soldered this one, but a while ago I soldered this one. So when this one fits already on the compartment size of the brass, I put this one inside, I cut this one, okay? And from the terminal coming from the motor, I soldered that one to this one here to connect brass number 1. Okay? So we need soldering here, plus a little bit of filing this one, so we could insert the brass to the correct, with the correct size, because this was a little bit bigger, you know. But there's no problem, like what I said, we could file this one so it will lessen in thickness, so we could insert it, then later on we solder the connections. Okay, I'll try to remove my soldering station. Okay. So to replace brass number 1, we just file this one to the correct size. We insert it, then we remove this connection here. Then we solder this to line number 1, the one coming here. Okay. For the other brass, it's the same. The size should almost be the same. So I will bring out another brass from my what do you call this? Both 10 sizes of brass contacts. The size of this one should be same as this one. So I will bring out another one like this. I try to file it to the correct size. Then I will insert it. Okay. I will cut this portion here. Then I will solder this portion here to line number 2. Line number 2. To maintain the proper connection. So when you will be getting your tester here and measure it, there will be a reading. Because with these contacts not contacting or connecting to the, what you call this, is a rotor portion. Because the contacts are actually in contact with the rotor portion, the one that rotates. If there is no connection, okay, there is no way that you could operate the leaf blower. Okay, so the replacement brass contact should connect to the rotating thing, the rotor thing. Okay, so there will be continuity when we try to plug into a power source. Okay, so it's just like that. I replace brass number 1 by filing it to the correct size, then I solder it to line number 1. I bring out another size of a brass contact. I file it again. I insert it, then I solder the connection with line number 2. So I didn't show you anymore. This is line number 1. This is line number 2. So this line number 1 is connected to brass contact number 1. And the other connection is connected to brass contact number 2. So this one here, line number 1 and number 2 are actually this one here. Okay? I bypassed the so-called switch already. So the only thing that to be needed here to power up, I eliminated the switch already. Okay, this portion here is the one to be inserted to the plug, and it's this one here. So for this one to operate, we just plug into a power source, okay, and the leaf blower will be live again. So just to show you that I have done the troubleshooting of this one by replacing brush contacts number one, and number two with the new one coming from by ordering it on Amazon. Okay, I was able to revive this leaf blower, which is actually a 20-year-old blower. So the motor is still fine. The only thing that's packing up or not working correctly is actually the brushes, because the brushes are actually worn out. Okay. So just to show you that this blower here is working good now, if I will try to plug in this one, this will automatically operate. Okay, so I'll plug in this one. The switch is still off. Okay, as soon as I flip the switch here, this blower will be alive. Okay, I will show you. Good afternoon from Los Angeles. This is Professor David J. Del Rey.